Yeah, good morning, ladies and gentlemen. It's a pleasure to start the presentation of the first Alpine railway systems. So I'll give you some insights on the high-speed turnouts. As mentioned before, my colleague Anna Cornish will then continue with information on the point operating equipment. And finally, and maybe the cream on the cake, is then the information from Richard Beardmore about our asset condition monitoring systems. Then we start the introduction of the first Alpine railway systems, because I had also some slides information about the first Alpine, which is our mother company. It's a public company in Austria with its stocks being traded at the stock in Vienna. It has its headquarters in Linz in Austria, has about 50,000 employees in more than 500 companies worldwide. And in last fiscal year, the turnover was about 15 billion euros. So the railway systems, First Alpine Railway Systems, is a part of one of these four divisions of the First Alpine. It belongs to the metal engineering division, and First Alpine Railway System itself has about 7,000 employees in 66 production, sales and service offices and locations worldwide. And we're having 3 profit centers for the turnout and fixations for the rail and the signaling components, and 1 competence center for the track solutions, where I can give you more information on this. And of course, we have 4 strategic business areas. One is, of course, the high speed. The second one is the mixed traffic. The third one, the MRT and urban traffic. And the last one, of course, the heavy haul application. So you see here the global map, where we've got all these 66 locations worldwide within the railway systems. And of course, important for you here, the locations in the UK with our company First Alpine Turnout Technology United Kingdom, with its plants in Edinburgh and in Haworth in Nottinghamshire. The First Alpine Signaling United Kingdom, with its offices in Fareham, close to Southampton. And of course, the colleagues of the First Alpine Rail Technology providing the rails to the UK. They also have their offices in Haworth. I already mentioned these business centers, so the turnout fixations, the rails, the signaling, and the competence center of the track solutions. So they're also active on all continents. And the goal is always to provide our customers with the best performance on their track, to support them and to build a long-term partnership, also to get feedback from them from operation of our products in order to improve our products further, to provide tailor-made solutions for our customers. So now about the high speed, of course, we already had some presentations in the morning session, so I am very happy that in particular George, but also Jaden provided information about some of our products, and in particular also with regard to the high speed application. And also Jan provided information on the gauge kinematic optimization, so I can skip some of my many, perhaps too many slides of my presentation, so thank you for that. So what we see in the high-speed area is, of course, there's a global demand of further high-speed lines for intercity transportation. There is a high competition with air travel, and this is, of course, with regard to global warming potential, an issue where, of course, governments are nowadays focusing again on the railway and on the high speed. And we see, of course, as a demand, raising speeds in the high-speed sector. So nowadays we are talking of about 300 kilometers per hour and more, like 360 for the high-speed 2 here in the UK. And of course, the passengers, they require or expect a high level of comfort and, of course, the highest possible level of safety, which is, of course, from my point of view, the most important issue. So what are our solutions in this area? So we provide our customers with optimized materials and, of course, geometries to maximize the safety and the comfort in the turnout, in the transition from the track into the turnout. Thereby, we also provide elastic track support systems, which are optimized to the elasticity and the deflection properties of the components in the turnout. In particular, important for application in slab track. Of course, we've got integrated signaling solutions, since we not only see a turnout as a sum of single parts, we really see this as a system and want to understand the whole system. And that's the reason why we'll also provide all kinds of products for this system. In particular, nowadays, more and more important becoming the monitoring equipment to assess the condition of the turnouts and, of course, to provide this information to the customer for his plans of inspection and maintenance, so that at the end he can perform preventive maintenance action. So this slide provides you some information about the range of products we've got within the railway systems here for the application in the high-speed sector, of course, starting with the rails themselves. Our colleagues from the rail technology provide premium rails, premium with regard to the material, so making research in metallurgical aspects, as well as premium with regard to wheel shapes and tolerances of these rolled rails. And of course, we make use of these rails in the turnout, in the set of switches with the asymmetric switch plate profile in order to enable the inner stock rail bracing, so to have more or less the same elastic rail fastening which the rail usually has in a track. Thereby we also have then switch rollers to enable, of course, the low friction changeover of the switch plate. For doing this, of course, we've got then locking devices. We usually apply external locking devices on high-speed applications in order to always have the sturdy and rigid fixation between the stock rail and the switch plate, in particular in the beginning where the stock rail is elastically deflected because of the application of high elastic base plates. And then, of course, due to the inertia of the mass of the switch rail, maybe there might be some relative movement. And so we have also tailor-made and developed mechanical locking devices to deal with this issue, like these HIS locking device, which I provide you a little bit more insight later on. So, of course, we've got then the point machines for these external locking devices, which, of course, are moving then these locking devices and thereby the switch rails and, of course, the swing nose crossing, or here as it is said, the movable point frog, which is maybe a little bit new to you in the UK in the application, maybe on a high-speed one. You know them, but you hardly have them here on the standard network. So this is also a must for high speed. So for the application for speeds higher than 250, the technical specification of the interoperability for the infrastructure, and now this is the new version here in the UK is then the NTSN, the standard for the infrastructure. They require the application of swing nose crossings for train speeds higher than 250 kilometers per hour. Then, of course, we have all kinds of different componentry to provide special functions within the turnouts, and also mentioned by Jaden the elastic coupling, which of course is used for the split bearer in application in ballasted track. Of course, in slab track, there's really no need for that. At least if you consider the operational phase. Maybe it is also of benefit to split long bearers in slab track application, just to ensure that you can transport pre-assembled turnout segments in the quality during the assembly in the turnout manufacturing plant to the site for the installation. Then you can couple them, the steel plates, and then of course everything is clear. So here are some main features. I want to skip the information about the double cloth weight geometry because George already provided. Then the kinematic gauge optimization, I only skip very fast. Of course, swing nose crossings, we already talked about that they are applied at speeds higher than 250 kilometers. The rail expansion device is also, George, thankfully, included into his presentation, and elastic base plates. So I can skip all these slides. Of course, here the kinematic gauge optimization, the swing nose crossings, the rail expansion devices. Of course, here these high elastic base plate system, which are tailored for the application in different positions within the turnouts with consideration of the deflection properties of the rail components. Then the elastic coupling, and here a side of this trial installation at Reading West. Of course, manufacturer, we also apply 3D CAD systems in our companies and having then an interface to machines, and so the CAD-CAM machines provide information about if we achieve the required tolerances in the production as we want to see them in the design. Of course, in our R&D, we perform verification and validation and, of course, test. So FEM modeling is standard for us, but also having then these multi-body simulations here, simulating the crossing of a high-speed train with a speed of 400 kilometers on a swing nose crossing, where you see in blue the reaction and the movement, vertical movement of the crossing block, and in red the deflection of the wing rails. And in the lower graphs you see these reaction forces due to the movements of these masses. And you see finally here we've got our own in-house laboratory to make full-scale tests of different components. So you see here a test of a swing nose crossing, or here in this way test of an elastic base plate system. And of course then, if all these products passed our theoretical and in-house testing, then we bring them to the test tracks of our customers. Here we've got a side of the UHPC, the high performance crossing here in the installation at Deutsche Bahn. Also a trial installation took place here at Network Rail in April this year. And of course we've got further customers who are very interested in this product from industrial railway lines. Of course, we also perform measurements then at the site where we apply strain gauges on these components. This is here an example on a high-speed switch in Spain. And of course, finally, we've got here this HIS locking device, which might be a little bit strange movement for you in the UK, because we have this asynchronous movement of the switch blade, and this HIS locking device is not only horizontally moving the switch blades but also vertically locking them in order to prevent any differential movement between the elastically bedded stock rail and the switch blade. So, thank you very much.
So this is where it gets electrical. Hello, I'm Anna Cornish. I'm working the signalling side, working closely with Burkhardt's team, and also Richard's on the condition monitoring. So once that locking device is in, that's naturally holding the gauge of the switches and also holds the position of the switch relative to the stock rail. Very similar really to the clamp lock in some respects, but it's got no drive. It is only a lock function. So we pair it up with an EchoStar drive unit, just a good old-fashioned motor with some rods sticking out the end. The rods connect to the locking device, and it has a secondary detection on it to also confirm that the lock is where it's supposed to be. So it's monitoring both open and close switch on both sides. So good little bit of kit there. All the usual stats that you'd expect now with modern standards and also UK standards. This particular piece of equipment is approved in many countries around the world, and I think it passes Senelec standards up to the speeds and shock and vibration IP rating as per Senelec standards. And I think the challenge laid down to us by George and the team is now proving that's good for 360 kilometres an hour plus contingency. So we're currently going through the process of taking the EchoStar through to proving it can function adequately with trains going past at 400 kilometres an hour. There's the typical throws, forces, details of the unit, really not that dissimilar to much of what you're familiar with here in the UK, certainly standard in a lot of countries. Situated out onto the side of the track into the CES, so easy access for maintenance as well, and it can be positioned lower underneath the stock so that it's providing that connection to the locking device from easy accessible positions really, and suits mid-bearer and on-bearer applications. This is a trailable. There are also non-trailable variants, but you've got a trailable device in there. So in the event that a train's doing something it shouldn't be doing, actually the machine will yield, the locks will go, and no damage done to the machine or the rails. Yeah, I think I said a lot of that already. There's a bit more information about it. Again, I'm sure there's nothing there that surprises people. It's a very standard unit, really. Very robust, very reliable. Electrics, also very, very similar. Cutout switches that can be adapted for many different interlocking systems. And, you know, the conventional 4/7 or even a little bit more if needed by the interlocking. We do a lot of work here in the UK with a company called Alexis, so we don't typically provide then the connection cables back to the disconnection box or the interlocking. We do rely on local people in the UK to tell us what's approved for UK and what works here in the UK, what the existing maintenance regimes are already in place, and also what is, plug couplers in particular, what is a better product, you know, the IP67, the shock and vibe. So we're also looking now with the EchoStar about how we can take the internals, the internal electrics and detection functions to make sure we carry on monitoring both open closed positions as a secondary detection and take that back to interlocking. So a lot of good work happening there. Motor, standard motor. Don't want to recreate anything new or different here, and again, depending on where the echo is actually in the length of the switch, because obviously the longer the switch, the more echo stars. Each HRS locking device needs an echo, so each motor though is the same. The only difference between the units is the distance that they throw, which is determined by track design. So very much look to make sure that the motors are as common and as consistent as possible and applying the same torque. Sensors can go in on pretty much anything these days, thanks to the work that Richard's team have been doing. So I think the biggest constraint for Richard's team is we don't give them a lot of space. We do use up a lot of that housing unit. So yeah, Richard has got a lot more detail on exactly what's monitored and where. So, but yeah, it's very interesting what is now available and what can be monitored when you look at these systems these days. Yeah, there's the detection loss trailing unit and independent. This is a secondary. The detection rods on these units are secondary, and I'll explain why in a minute. And there's the sites that we use EchoStar currently. Main reason the Echo is independent as secondary detection, so is because it's actually monitoring what the lock is doing. So it's not, if the lock obviously has failed in some respect and is not picking up the exact position of the switch, then we need a secondary or primary detection, which is actually looking at the switches, and that's where the IE2010 comes in. The IE2010 sits neatly in the forefoot, out the way, and it's actually looking at just the switch alone. It's a detection unit only, it's no drive on it, no lock on it, so it's completely following what the switch is doing and looking that the switch is in correct position, be it open or closed. So it's effectively got the 4 in position switches within. It sits on bearer or on slab, can obviously then be mounted directly to slab, so it's a relatively passive and peaceful unit. And yeah, maintenance is amazing. It's pretty much an annual check. It's electrical. If something goes wrong with electrically, you can see that straight away. So that's all the bits and pieces and what it does. Got the earth strap. And the connections to the switch rod do allow for thermal contraction expansion. And there we go. Right. So yeah, fairly passive unit, but very integral to the safety case and safety argument for demonstrating, particularly on high speed, the safety of the system and the verification the switches are where they're supposed to be. Then the other little product that we have here in the UK now is the Unistar HR. This is a integrated lock drive detect unit where everything is in the one box. And hydraulic power pack sits outside. That can be up to 20 metres away. The drive locking unit will be within the switch rails, 4-foot mounted. That can be on bearer mounted or mid-bearer mounted, depending again if it's on slab track. So much the same as the EchoStar, designed to Senelec standards. We have the supporting safety cases with the ISO endorsements, SIL 4, IP67. Yeah, all that good things that you'd now naturally expect with any point machine. Fully trailable as well. And there's a few more facts and figures about the Unistar. Goes up to a 160 throw opening, can be as low as 34 actually we've developed for one of our Australian customers. And throw time 2 to 5 seconds. The hydraulic unit itself can power up to 4 drive units, so it can be good for certainly up to something like an SG switch length. And fully adaptable. Lots of positions where the drive unit can go. Drive can even go outside of the running rails, like for example on narrow gauge lines, we put it outside and then it bring the rail connections in to position the switches. Each switch is driven independently, and again, if there was the event of a trailing event and the machine was trailed, the locks can both yield to both switches and allow the switches to move independently. So, on bearer, fully tamperable. Hydraulic unit, we even managed to, Paris Metro, position the hydraulic unit on its side against a wall, and it still worked perfectly happily. So that was quite amazing, really. And I think for New York, we've also, after the flooding events a few years ago, got an IP68 machine now at New York, which was a lot of development, actually. And I think that picture there's actually Australia. So Australians are now asking for plug-coupled IP67 connecting cables to the hydraulic units, as well as looking at the IP68 machine. So a lot of adaptations going on now for what is going on with the environmental changes that we're all seeing in the world. Weight-wise, it is a modular point machine, much the same as the Echo, so we don't encourage maintenance within the unit. If it doesn't work and you can't visually see why straight away, we do just encourage a straight change out. Get the unit back to somewhere where it's safe, somewhere where it can actually be inspected in normal conditions, well lit, and out of the rain and the snow, and look at what's wrong with it there. So the whole system, including the Echo and the i2010, is very much designed on that modular philosophy. And hopefully this YouTube video, no, sorry, how do I, there. And everything we do as well is all in SolidWorks and CAD, which gives the advantage that hopefully this video will show. it going to work? Is it going to work? I've sunk the system. Yay.
First albino, one step ahead.
So all our drawings are
First
in the...
albino, one step ahead.
Jump ahead quick. Yeah, everything is in SolidWorks and other CAD modelling formats which enable us to produce fantastic videos like that. But what that also means, though, is when we are working with customers about how the Unistar or the Echo or any of our products actually work into either existing arrangements or new track designs, or as we're working with Burkhard and Richard's team now, we can create that full system drawing and do the clash checks. It obviously assists them with any design reviews. You can see where the difficult access points might be, and also where, for Richard getting sensors into the units, what our space constraints are. So our technology and the drawings also supports BOM, amazing part number management as well. It's amazing the level of the detail that goes into that and the sheer amount of part numbers. But that makes it easily traceable then for the future for replacement parts and working with the teams on, I think we recently had an incident in Australia where they managed to tamp a point machine. I don't really know how they managed it. They've done some amazing damage, but at least we can just look at the drawings with them, work out exactly what they broke, and then we can just send out the replacement parts. We also... Senelec obviously looks to approve point machines to 10 years, million cycles. We know our machines do go a lot longer than that, particularly if they're taken well care of, and we're not interested in every 10 years selling a new point machine, for example, or every million cycles. So we do a lot of work with customers where we, after a set period of time, happily go out and have a look. Just say, right, what's working, what's not working, what's breaking, what needs overhauling. We know the hydraulic fluid, for example, does need changing out about every 10 years, and some of the seals. But if that's all that needs doing to a unit, then why change it? Leave it. We can help with the overhaul process and then provide an extended warranty for a further 2 years just to keep that point machine going and hopefully see it through for 20 years actually in service. So from longevity of the point machine and trying to prevent unnecessary change-outs. We certainly on the tram networks here in the UK, we're doing a lot of work with some of the tram teams at the minute of helping with their asset condition surveys and also asset management. Now they've got 10-year-old assets of ours. And then training. The COVID really showed us how we can do so much training online, and we had to carry on doing training online. And with those models that I showed you there, we can actually turn a lot of that training into 3D and artificial intelligence and also the use of goggles. And in a trans last year, we did actually have a team there showing us how you could teach maintenance through the use of goggles and AI. And the whole concept of using your hands like this on screen, it blew everyone's mind, but it did really make us realise that training is not these days coming into a training school and actually face-to-face. Yes, you can't ever take away the face-to-face, but there are so many other ways you can do it now. Through the use of just having images on your iPad, some of those images I showed you there can be broken down into maintenance tasks. And that is certainly where we're trying to go. Okay.
Oh, thank you very much, Anna and Burkhard, for your introduction and kind of bigging me up ahead of this section. I'll start off by saying that I feel like a little bit of an imposter here. My background has been in rolling stock and signalling monitoring systems, so track and turnouts are very much not my area of expertise. However, I am an IET member, so, well, welcome to my venue. The title I've given to my section of the presentation is Thinking Beyond the Retrofit. I've been told by Darren et al. That you're all condition monitoring experts, so I'm not going to go into the basics of condition monitoring systems, but what I'm trying to think about is what we're doing next with condition monitoring. Obviously, as you know, there's always new sensors coming in, there's always new technologies for getting the data and processing it, but I think one of the big things that we're coming up to at the moment, and is going to be a big deal with the likes of HS2, etc., is thinking beyond tacking the sensors on afterwards, putting them on legacy systems, putting them in as an afterthought, and really designing them in when the turnout is designed, when it's manufactured, making it an integral part of the turnout system. But of course, couldn't say about that without saying, obviously, there's a lot of installed base railway assets around. We already monitor around 40,000 assets globally in many different countries, over 10,000 points machines. So the retrofit is not going away. That's something we already do. You've heard a lot about it already, so I'm not going to reiterate that. But one thing that I will say again is that it really does work. So looking back at the data from our Roadmaster software platform, tallying that up against maintenance records, etc., reductions of 40% in turnout failures for monitored turnouts versus unmonitored really is achievable. So it's certainly something to think about when planning in not only new turnouts, but also for existing install base. The monitoring that we provide is divided up into a number of different categories. Today I'm going to talk to you about switch condition monitoring, a little bit of signalling power, and also the track and rail monitoring side of what we do. But we can bring those all together in one kind of combined monitoring platform. The main thing to talk about today, obviously, we're talking about turnout, so it's switch condition monitoring. I'm sure a lot of you have seen this already in turnouts around the world, from monitoring of hydraulics in points machines through to electrical drives. There's a number of different ways to do it. There's a number of different solutions for sensors and monitoring architecture. But the thing that we're doing that really is novel in this is thinking about it at the point at which the complete turnout is designed. So we're talking stop rails, switch rails, points operating equipment, asset condition monitoring, all together as a single package, using the expertise of those different areas to inform each other's designs in order to provide a system that truly is combined and leverages the best of the knowledge in all of those different areas, and is also hopefully easier and cheaper to install rather than trying to do something and bolt it on afterwards. I'll give you an example to begin with. This is one of our points machines. Anna mentioned that we didn't have a lot of space, and she really wasn't joking. But that's where including the monitoring as a part of, for example, the manufacture of points operating equipment really is key. Trying to retrofit pressure sensors, oil level sensors, fluid ingress, etc., to one of these machines would be difficult to the point of being nigh on impossible. So by having it installed in the factory, not only do you get the benefits of the quality, obviously, historically, condition monitoring systems are generally SIL 0 or non-SIL, but getting the benefit of that higher integrity build not only increases the quality of the installation and of the equipment, but it also means you're putting the sensors in the right places, designed in at the beginning. In addition to what you can see here, we're also developing other types of sensors for points machines. Obviously, we can do monitoring of electric points machines. You can do hydraulics, air operated even. But we're also going beyond the direct sensors in the units and looking at something like a structure-borne acoustic sensor, which is something that I'll come on to in just a second. And obviously, some more basic sensors such as fluid ingress, because now and again everyone forgets to put the lid back on. Another part of our integrated turnout sensor system is a rail position sensor. This is not a new development for us. It's something that we've trialled and used in various sites around the world. But by bringing not only the point machine monitoring, but also putting in sensors for rail position allows for measurement of things like your toe position, minimum flange way, rail position, etc., to sub-millimetre levels, and that allows it doesn't take away or replace safety critical checks at the moment, but it does allow you to detect the degradation that you see in a turnout system and how a given turnout is behaving with age. They're robust, reliable, solid-state sensors, obviously all rail approved with the relevant vibration, thermal, EMC certifications. But one of the advantages of designing these in at the start when the turnout is originally designed is you can see a bracket here which is a little bit more of a retrofit but closer to it, but there's possibilities of integrating them within base plates, having it truly as a part of the turnout when it's delivered. The next sensor that's a new development for us is the structure-borne acoustic sensor. This is a sensor that is fitted not only to points machines, but also can be fitted to rail web and crossing areas as well. And it goes beyond the level of just a pure acceleration or a vibration sensor. It monitors a number of different frequencies and can effectively listen to the condition of the turnout. And by adding that, you can really add some additional knowledge about what's happening, particularly in the crossing areas. You can detect transition points as well as where in crossings as well. It's an interesting sensor. It's something that we're deploying at the moment in various different areas, but it does require some new thinking in rail. This particular sensor, to work at its best, requires adhesive, which obviously is not a standard or known process within the rail industry. I'm sure the automotive industry would have said the same 50 years ago, but as time moves on and material properties move on, we need to think about moving with the times and how we can use these technologies to our best advantage. Data transmission. We design and build our own data loggers in the UK for various different applications. We can communicate over fixed communications networks or mobile data networks. It's very, very common to use a range of different communications technologies. Obviously, we have to be flexible to the particular railway that we're working with. And for each turnout, for each integrated turnout, you would generally have a collection of data loggers and transmission equipment and a point for the sensors to come together next to the turnout. But again, that's designed at the point that the turnout is designed. Turning data into information, lots of data from lots of sensors is fine, but what we really need to do is to be able to tell operators and maintainers what to do about it. This is where an integrated software platform like our Roadmaster system comes in, takes data from different asset types, different sensors, and brings it together into a point where you have the alerts and alarms that operators will be familiar with, and hopefully tuned by the integration of the sensors and the condition monitoring within the turnout, tuned to minimise false alarms and to maximise the benefit of the data that we provide on the turnout that we're monitoring. Just a little bit about the turnout integration. So again, I can't emphasize enough the importance or the usefulness of being able to test and prove the sensors as part of turnout operation. It means that cable routes can be planned in advance and built in advance. It means that brackets can be integrated into the system to improve the quality of the installation of condition monitoring, and again, improve the impact that the condition monitoring system has on safety. And lastly, a little bit of technical detail for you. I mentioned about the structure-borne acoustic sensor earlier. One of its uses is in crossing wear detection. Here you can see a couple of worn crossing noses, and we can use this sensor in a novel way to be able to detect the health of a crossing and give what we call our crossing condition index. This is a system by which we can not only by which we can not only count up and correlate the number of train movements and the types of trains that are moving across a crossing, but it also means that we can detect the gradual degradation in a crossing, the movement of the transition point, etc., and hopefully be able to allow the operator to intervene before the system fails. And last but not least, I want to mention a modular approach. Obviously, you're sitting here thinking about all these different sensors I'm telling you about, and obviously every new turnout that you specify, you're going to want hundreds of different sensors on, but it's got to be proportionate. The biggest the biggest turnouts that we're providing, for example, projects at the moment, with 13 setting levels, will by their nature require a lot of sensors and things, but there's also an argument to be made for turnouts within depots, simpler turnouts, still to have an amount of condition monitoring, but an amount that's appropriate to the location. And that's why we advocate this modular approach, where you can have as many or as few sensors as possible, but by designing them in with the turnout at the start, you have the advantage of the knowledge that our teams have got working in a combined way to provide the appropriate monitoring in order to meet the cost that's required, but also try and improve reliability. Thank you very much.